now I need plotting. So, Python, one beautiful thing is it can really plot complex functions, okay, and it is quick and also integrated with the coding, with programming. Okay. If I am programming in C, plotting is way too difficult. There are some libraries, but nobody plots in C as far as I know. Well, some old guys may, but nobody does plotting in C. Okay. Either use all these packages, MATLAB, Mathematica or Python. So, I'll show you how we can do things with plotting. So, from the help, by the way, I just had to quit, otherwise I won't get that interpreter in one out one. So, quit, I got it here, so I should make it. So, next 2 classes I will just do plotting. Okay. So, I think 1.5 class I should finish. So, this is part of PyLab. So, you do not need to do anything else, just IPython ---- PyLab, and I want to plot. So, let us say plot x comma y, no? So, x is an array, y is an array. So, it will plot 2 arrays, linear arrays. So, I am doing 2D plot. So, let us say I plot for oscillator. Okay. So, oscillator I start from time t equal to 0. So, I should use linspace. No? So, time 0 to 2 pi. So, linspace is a very useful function, 0, 2 star pi. So, please see this. Okay. Everybody can see this. So, lin 2 pi, and how many numbers do I want? 100 is good enough. Okay. So, do not put too many of them. So, 100 is good. Okay. So, this time, t is time. I am looking for x. So, x is sin t, frequency is omega is 1. So, x is sin t. Now, I want to plot. So, it's trivial, plot t comma x. Okay. So, it has come in the background. So, this is what has come. So, x is 0 to 6 point what is it 28. So, I do not like this this area. I mean, it looks as if it stops, no, the oscillator does not stop. So, we say, well, I want to make the x axis 0 to 2 pi only. So, there is a function called xlim, x limit. Let us put it slightly inside. So, you say xlim. So, PyLab is very nice, that way I do not need to remember is part of matplotlib. This is all part of matplotlib. Okay. Remember this function I was telling you, the package matplotlib. So, I do not have to say matplotlib right now. PyLab has imported all of it and is making me available. So, x limit will take an array. So, limit of x minimum to maximum. So, it is an array. So, I have to put within a bracket, square bracket, 0 to 2 pi. Okay. So, 0 to 2 pi I limit my x. So, now if you see the plot, it did it, it corrected it. So, 0 to 2 pi here. I could also write this label in terms of pi in 2 pi. Okay. This is called x text. I will not do all of it live, it is like I also do not remember all the syntax, but I will give you these packages and or rather my functions, and you can tinker with it and you can write it. I want to put label. So, I want to put label here and label there. So, it is very easy. So, x label. So, you will label the x axis. Even though I call x axis as t, x label is a keyword for the x axis, okay, even though it is t. So, do not say t label you do not understand, it is x label, and you have to say t within quotes. So, if I just say t, let us say just put t, it will work, and I will put t below. Okay. So, t has been cut, but we can also when I save it, it will come okay, but this t should be math t. So, it also takes LaTeX syntax. So, LaTeX, if you remember, math is in dollars, no, LaTeX is you should be knowing LaTeX, or if you do not know, you kind of learn slowly. So, you put LaTeX symbol in dollars, this is for LaTeX. So, it is a string, now it has T, so it is overwritten it, so T is there. Now, I put a Y label, quote dollar okay. So, you can see that xt is in the right. Okay. So, we can easily do plotting. We can save this plot. How do I save this plot? Or we can zoom inside the plot. So, you can zooming in, you can do by this. I can zoom in this part, but you want to go back, so you put this home. I want to save it, you just click here and it will tell you where to save it. Okay. So, I can save as figure 1. So, this is saving as PNG. So, this is the format. I want PDF, then I just say PDF. So, PDF is one. You can change the name of this file. So, all of it you can save, it is saved in, well, I mean wherever you want you can save it. Okay. So, I will not save it here. Now, I want another figure. So, that let us say is energy x squared. So, to get another figure I say figure like this. So, it has created figure 2, figure 2. So, figure 1 is there behind, okay. Figure 1 is definitely there. So, you create another figure. So, windows, so you should be seeing figure is somewhere behind. So, I want to plot x squared. So, I say plot t comma x square is this, x is an array, right. So, x square will work, but I want with some other color. So, I go say red dot, so this will be dash dash. Okay. Wait, so what is this red? It does it require in a string, it is a string. So, it is red with dash dash. Okay. So, all that you can find in help, you want chain, so it is dash dot. So, you can do lot of stuff very simply. So, in your course you can in quantum mechanics or something, you can simply plot, you do not need to believe the book, so book is, you can just see whether it is correct or not. Some book plots are wrong, okay. I can tell you that one. So, you can see yourself. So, this is how we do it, but let us do slightly systematically. I want to make this figure more nicely. I want the size of the figure. So, if I make it too big a figure, then when I shrink it, the font becomes small. Okay. So, I will just run some of this stuff for 2D plot as well. Not everything you need to do it, but I think it is a good idea that you learn some of this, how to tinker with the size. So, in your report, when you write for project, you should be giving a good figure, or for your other work. So, I will just go through the codes which I have written. In fact, this is by Abhishek, some of it was done by the PhD student. So, this PyLab I just showed you. So, this is what I just did that. Okay. I can change the size of this label by saying size is 20. So, this is called 20 points, in each point is some inch, 20. X limit you can set the Y limit, you can do all that. So, this is a figure, there is 2 of them. You can combine many figures in one command, or you can put 2 commands, different colors. So, this is a figure. I inverted my, so the color coding is not exactly same as what I put in the code, because in recording the white does not look good. So, this has been changed. So, a color will not be exactly same as what you, so I will share the PDF file, and the PDF file the color will be exact like what comes from the code. So, let us look at some of the commands. So, you can make a file, you do not need to say x label, x limit, y limit all the time. So, this file we can change only some parts and you can plot, beautiful plots. So, this is one of the file for plotting 2D. So, you go from the top, the file will require the packages, without that it will not plot. PyLab has imported all of it, but the file does not know what PyLab has imported. So, I need to import this called matplotlib, and I import as PLT. Now, this part is nice, so it is part of PyLab called RC parameter, and this tells set the size. The figure of size 5 inch by 3 inch. Okay, so it's a nice 5 inch by 3 inch, fits nicely in a page, in a book page. So I want to plot x squared and x cube. So linspace again -1 to 1 with 10 points. So I plot x comma y with red dot. So this will be dot will be, I am not sure, it should be dot, I forget usually. So dot is probably dot. Label, so I am putting the label of this plot. So you will see label will come. So this is called legend. Okay, so legend tells you which color is what. So I'll show you the figure. So this will plot x comma y, and it is y equal to x squared, and next one is y equal to x cube, is color green. Okay, color will not come out right, as I said I have inverted the color for video recording. This for axis. So this sets the axis, x axis and y axis, horizontal axis and vertical axis, h and v. So the horizontal axis, vertical axis. I set the limit -1 to 1, and also the color of is x label and y label. I put this legend at some location 4, right corner. The figure looks like this. Okay, it looks good, no? The figure is, so this is dot, what I was telling you, and this is that x cube, and this is a legend, this is called legend, and this is x axis label and y axis label. So you can create this figure which looks nice by running that command. So if you want some different function, you just change those functions, and this, so we reuse it, so you just change it and reuse it. So this is for 2D plot. Now we can do vector plots. So in electrodynamics we have all this electric field and magnetic field. So I am going to do a simple vector plot.
So in the previous one, where did we use the data of the file?
Data of the what? Achha, where did I save it? So I can save it. So I will show you in the next plot. So where do you want to save it? I will specify in the next plot. You are wanting to save the PDF file. No, I didn't plot from file. All the data is here. So this x is linspace, y is x squared. All the data is here. I am not importing any data. So all the data is generated here in these 3 lines. You can import it, but I have not told you yet how to get data from a file. Now I want to do a vector plot. So this is minus r. So this, where does it come? This minus r force field. So 1 over r, 1 over r squared. But where is minus r? So my force field is minus r vector. Bold means vector. Okay. So what is minus r? 2D. Sorry, harmonic oscillator. I did in my course. Okay, last time. So don't tell me that I didn't do it. So force is minus r is oscillator, which is 2D oscillator. I did mention it, I believe. So for molecule, if it is attractive, is minus r vector, I mean near the equilibrium point. Okay, but it is in more than one dimension. So the vector field is, you plot like this. So this part is exactly same as before. This is called color method, the CM color something, CM, I forget what M is for. So this is for coloring, which we don't need it actually, this part of something else. These two are not required, 3D right now. So x data and y data. So I need to make a grid. So at each grid point I will have vector. Okay, you have to be careful about these 3 lines. So my x data is from -1 to 1 and y data is from -2 to 2, 10 points each. So there are 100 points, but the range is different. I can choose the same range. Actually, I think it's -1 to 1, I believe. So there's bit of change in my code and here. So xv and yv. So this is obtained by mesh grid. So this part of numpy array and is mesh grid x comma y. So I take this x and y and I create a mesh grid. So what is xv? So xv is 100 by 100 points, and each position will tell you the x coordinate. So this mesh is very useful function for all plotting in a mesh. A mesh is, in this room I make a mesh like 3D grid. Here it is 2D grid, but each point I want to know what is x and what is y. Okay, so this is xv, you can print xv and you will find that for a given y all the numbers are same, is xv, and yv will give you y coordinate at that point. So xv comma yv will give you at any position, it will tell you what is x and y coordinate of that point. So, this mesh grid is very commonly used in plotting, not only in Python, but in MATLAB or even higher ones for fluid solvers or electrodynamics. Now, I create a figure. So, PLT is starting, now I am going to start using PLT. So, this is part of matplotlib. So, this will create a figure. So, every time I invoke this, I create a new figure. This will create a figure. Now, this quiver is an arrow. So, you will create arrow at this position x comma y, okay, in the mesh. So, just imagine this is a mesh at each point. So, the first two coordinates will tell you. So, this is a coordinate. Okay. So, what is the vector field at that coordinate? So, the vector field here, yeah, that is fine. So, I am putting what, so here the coordinate at that point is x and y, xv and yv. Okay. So, here this is just going to create a vector field. So, if this is the origin like this, okay. So, this creates this arrow has x component and y component. So, these are the x component y component. So, these are location of the coordinate and this is a arrows components. So, it looks like this. Okay. So, when you go further away, it is size is increasing and it is all going towards the origin. Origin is sitting somewhere here 0, 0 and it is all pointing towards that. Okay. So, this is simple one, but you can create more complex vector fields. So, let us get to this plotting using files. So, when I plot for my writing research paper or for making some plots for some stuff, then you have a file prepared already and you change the functions, change few things and we will reuse it. So, that is the main idea. So, let us go through. So, this is a 2D plot like what I did for x comma y. Okay. 2D is x comma y, well, x is x axis, y is vertical axis. So, these are stuff which I have put on the top. I would need numpy many times. So, I keep numpy here. Matplotlib. So, import as PLT. This again is standard. You will find that this is standard practice followed, PLT. So, this for plot. You do not need to write all this, just say PLT. This is for getting the figure size right. This is going to create a figure of 5 inch by 3 inch. I want the size of the figure from at least my research paper or from my book, not arbitrary size. So, we control the size of the figure, which is easy. So, you just put it like this. So, this is called parameters. Okay. These are parameters of PyLab. In fact, you can see what these parameters are. So, I will not get into it. These two lines achieve this task of 5 inch by 3 inch figure. Now, I want to plot x comma y with a function as x squared. So, I first create a array, numpy array, it -1 to 1 with 10 points. So, y equal x squared and y1 is x cube. So, I will plot two of them in same plot. So, PLT dot plot x comma y. So, this is going to plot x comma y with red dots. Okay. You can choose different colors. So, if you do help of plot, you will find what is syntax for different color. Blue is B and black is K and so all that. I can put a label for this plot. So, if you have many plots and you need to know which is corresponds to what. So, this is nice function feature. So, it puts a label for. So, I will show you when you look at the plot, you will find that y equal to x squared corresponds to red dot. It tell you that this is red dot. Okay. So, this is nice feature, you will find it. Now, the second plot x cube is x comma y1. This is called line width, LW. You can write full line width, but Python also understands shorthand. LW is 3 points. So, it is thick. So, I find this thick. Color is green. I could have said just quote. So, I need not have put this, but there is another way to write it. And label is this x cube. Why? So, this is in LaTeX. Dollar means LaTeX, x cube. Now, this will. So, this is horizontal line. So, it puts the axis with color black. K is black. This vertical line with color black. Now, I want. So, if I do not control my limits, x limit and y limit, it may choose its own, it may put something else. Of course, my plot is from -1 to 1, but I want my x axis to be limited by -1 to 1, suppose, then I say x limit is -1 to 1 and y limit -1 to 1. This is optional. I can put labels for the x axis and y axis. So, this is x axis and y axis. Font size for this size 5 inch by 3 inch, this is good size, and I will put the legend at some location. So, location 4 means right corner. So, you can control where you want your legend to be. If you do not do it, then Python will decide, but we can also control. Now, I want to save it as some file. So, PLT save fig. So, we will do the save figure and name of the file will plot2d.pdf. It will be in the current directory. Now, quite a few of you are struggling with directory, my file is not running. So, you have to be in the right directory. So, please do Unix tutorial which is not difficult, just it will take you half a day or maybe 1 hour for this simple stuff. So, this plot2d.pdf will be present in the present directory where you are working. You can of course you can go to some other directory by saying ... some other directory. So, this Unix thing you will understand, and if I do not put this, it will not show. So, it will plot it and save it in that figure, but it will not show up on the screen. So, this is also my output, I want to see on the screen, then you have to say plt.show. So, show on the current graphics screen. So, this will achieve the task of plotting 2D. So, this is how the plot looks like. So, this is x squared y squared, and you see actually now this color is not red because I converted, I have inverted the color, okay, this for visualization. So, this is not exactly same as what it comes in the plot. The reason this white does not come nice in the video, that is why I just converted to black background. So, it will come with a white background, but this has been converted, background has been switched. So, this has become, this is the x squared and this is x cube, x is x label, y label, and this is called legend. So, this means x squared, x cube. So, it is easy and I can recycle it. I want something like sin x, I just need to change where one of the lines, no, you can add stuff. So, this can be recycled. So, now let us look at another figure. Vector plot is useful, electrodynamics, no, lots of vectors. So, I want to plot minus r vector. So, actually minus r cube, I changed it. So, r looks too trivial. So, I made it r cube. So, I must say this r cube. No, actually it is not r cube. So, let me just, so it is a 2D vector, it is x cube comma y cube, it is not r cube, apologies. So, I am plotting vector r, vector v is this, okay. So, this is my, suppose somebody asks you to do this vector plot with a minus sign, I think I have minus sign here, okay. So, let us see how to do it. Most of it is same, I do not need these two lines for this figure, but again copy paste it has come. I want the figure size to be 5,3. Now, I want to make a mesh. So, in 2D plots for vectors we will make a mesh. So, mesh is a grid, it is a grid, okay. Now, each point will correspond to some x and y coordinate, right, and Python will put a vector at that point. So, for mesh I first create, so what is my x coordinates and y coordinates, these are my x and y coordinates. Given these x y coordinates I create a mesh grid, I take this function mesh grid of numpy and create these two arrays xv and yv. So, this is an example of a function which gives you two outputs or two returns, it returns two things, two arrays. So, function can return number, string, arrays, multiple arrays, it can do lots of stuff. Right now it returns two arrays, and if you can plot, or rather you can look at it by just saying xv, and xv is a 2D array, not 1D array, it is a 2D array. In fact, xv, if you look at that array, it will be, suppose I want to do 4 by 4, okay. So, the first entries will be 4 numbers which will be same x, this same x, sorry, no, same y. So, it has same y. So, here numbers will change 1. So, this will be x0, x1, x2, x3, next one will be exactly same x0, x1, x2, x3. So, it will be 2D mesh, but now quite a few numbers will be common. So, it is the x coordinate of each point on the mesh, is that clear? Same thing with yv. So, it will give the y coordinate, okay. So, I will again have 2D array. Now, this point I want a coordinate, then I can get from xv, what is this, is the x is changing, and comma yv. So, coordinate of any point on the mesh is contained here, and that is what matplotlib will use. Matplotlib will use this coordinate and put some vector at each point. So, this is a nice function plt dot figure. So, I did use it last time. I did not say plt dot because it is part of PyLab in the screen. So, once every time I say figure, it will create a new figure. You do not want your figure to be overwritten. So, it creates a new figure, and the new function of matplotlib called quiver. Quiver means arrow. So, you will make an arrow at point xv comma yv. Okay, that is the mesh point. And what are the magnitude of the coordinates x component, y component of the vector. So, the x component is minus x cube and y component is minus y cube. Okay, so, they will create a vector at each point, and I know the coordinate, what is the coordinate is xv and yv at that point. Okay. So, this is going to achieve the task of making a vector plot. So, we will make a loop, but all that we do not need to worry, matplotlib will do all that. So, now this is standard stuff I showed in the last slide, x label, y label. This for ticks, I can control where should be my ticks. So, it says minus 2 to 2 with 5 points, 5 ticks, not 5 points, 5 ticks. Y ticks also can be controlled. I want my aspect ratio to be equal. Python sometimes does not make, well, most of the time it does not make aspect ratio equal. Normally you have plots, in fact this is standard, this is good. X axis is always most of the time bigger, no? You know why it is bigger? Why do not we plot mostly square, or like the playing cards, it is not square. So, why isn't it square? Your rooms are typically not square. Differentiate. One thing is that people do not read nowadays, they should read some books. In fact, you can look at this playing cards or a lot of stuff. The ratio is supposedly the most pleasing ratio is the golden ratio. Now, that is artists say it, okay, I mean I do not have proof. So, what is golden ratio? So, root 5 plus 1 by 2. Okay. So, this is 1.6 something. Okay. So, this is supposedly people have done some experiments, and this looks most pleasing. So, normally square is not, will be the size of like your card shape. So, plots are not typically squares, but I want square here. So, I want it to be realistic, otherwise the arrows will look jagged. So, this is that aspect ratio 1 figure, and these are the ticks, okay, minus 2 minus 1. I want this, these are ticks, you see ticks, and this x cube minus x cube comma minus y cube. These two contrast, I mean you can make different colors, you can make it better. So, this for 2D, 3D will be, I will make the new next one is 3D. You can also make 3D vectors. Now, 3D vectors, the only couple of changes we need to do is a 3D plot now. So, this is going to be minus r vector. So, now I need a function is this mplot 3D. So, this line has to be included. So, this MPL toolkit, now this I just copy from, this is my imitation, I just imitate some good programs, copy. There is no shame in it, okay, I mean it according to me, but you should understand what you have copied. So, this is called color scheme. So, this for sometimes I will show you where I need it. For this plot again I do not need it, but this has been again copied from different files. Now, this is called GCA. There are several ways to do it. If you play around with it for a day, you can do this 3D plots in many ways. One way is to declare your current axis. GCA is get current axis is projection 3D. So, this will tell you that my plot is 3D, otherwise standard is 2D. So, here I declare that my plot will be 3D. Now, I create this 3 XYZ arrays minus 10 to 10, only 5 points, right. And so, this is creating a mesh. Now, this is a 3D mesh. So, I am making in this room 3D grid. At each point, the coordinate of each point will be xv comma yv comma zv. Now, again I use the same function quiver, but since I declared it to be 3D, I have to give 3 coordinates and components of the vector, 3 components of the vector. And what are the 3 components of the vector? These are the 3 components, minus xv, yv, minus yv, minus zv. Okay, this standard, I mean of course, if you are forgetting the syntax, then you can put question mark plt.quiver in that IPython window and you will find the answer. I can save this figure in vector3d.pdf, and so this will show, if I do not put it, I do not come on the screen, but I want it on the screen. So, it will come on the screen. Now, how does it look plot? Okay, so this is x axis, y axis and z axis. Now, this is definitely not looking very great, but so these are the arrows. One can do better. If I work very hard, then you can also rotate this stuff, this screen. So, maybe towards the end I will show you how to rotate it, but the PDF file can't be rotated, but the file in the PyLab, it can be rotated. So, 3D stuff is nice, very simple, you just with the mouse you can rotate. So, we can do surface plots. So, now why do somebody do surface plot? I am looking at temperature of a plate, so this is a plate. Now, every point on this plate has a temperature. Now, I want to visualize it by plotting. So, how many ways can I do it? How many ways I can represent the temperature in a plot? One is contour, excellent. Second is surface. You eat on the each x y. I make, well, basically this x axis, y axis, and the distance along z axis will give me the coordinate of the surface. And there is another one. What else? What is that? Density plot. Okay. So, here I make this hot is red, and cold is blue. So, I make this picture, and that is where I need a color map, and then I say, well, in fact that is very nice actually. By just seeing the color I can see which is hot and which is cold. So, these are 3 ways you can make plots of a scalar field. You can also extend it to vector field, and vector field, the arrows size will of course tell you the length. You can make arrows colorful. So, we can also do for vectors similar ideas, but let us just stick to surface. Okay. So, surface plot is one way to do it. So, I am just looking at 2D. If his function is 3D, so I am looking at temperature of this room. Now, it is not possible to do surface, right. Why is that? You will go in the 4th dimension, and that is not possible. You can take a cut, of that cut you can show surface plot, but this is typically used for 2D. So, it is very similar to what we did so far. So, this will be 3D. So, z axis is my temperature, which is x squared plus y squared. So, I have to tell this 3D. This line will be common to what I did in the last slide, and I am making my x array and y array. Now, I create a mesh. So, this is a common stuff. So, you have to create a mesh. Now, this is z function, x squared plus y squared by 2. Now, to plot it, I have to say plot surface. So, this figure has one attribute axis. So, this axis is a figure has a class. Anyway, let us not get into it. One variable of this figure, which has properties of the axis. So, this axis is also important variable. If you look at my slides and you read up a little bit more, then you will understand. So, here I am saying axis dot plot surface. So, sometimes you will get an error. So, this function belongs to axis variable. So, these are layers of objects. So, like I want to go to a house, I have to go to first inside IIT, then take a street, then another smaller street. So, this is how you can think of loosely. So, this is plot surface is part of this axis, and I have to just say x y comma z. So, it has 3 variables. This is x coordinate, y coordinate, and z is a vertical coordinate. Now, this part I just copied. So, this is color scheme. So, color bar, so it will show you the color bar. Different colors mean different values. So, x label, y label, z label. Now, this is also nice. Sometimes you are, I will show you what this tight layout means. This is useful, and I am saving in a figure, saving in a file. So, the figure looks like this. So, it also has color. This is lowest blue and yellow is highest. It is not very useful here, because from the surface I know which is high temperature, which is low temperature, but it will be useful in the next couple of slides. So, this is x axis, y axis, and this is z axis. So, labels are also here. Sometimes when I save it, the x will get cut. So, it kind of exceeds it goes outside the window. So, the tight layout, the function which I just showed you, this is useful, it just puts in the appropriate window. So, this just gives you a better figure. Okay, so, this surface plot. Now, I want to make a contour plot of the same thing. So, well, it's a different function, minus log square root x squared plus y squared. So, the x array, y array, this is my function z. Now, I can do like this, curves equal to plt dot contour. Now, how many contours do I want? I can control here. I want 6 contours. So, I want 10 lines, I can increase the number here. Now, I can also put color bar. So different contours means different things. You can also put values of the contour. I have not done it here, but you can easily find how to put values of the contour. Now rest all is same, so let's look at it. So this contour plot, lowest is 15 here. Now computer is choosing by its own. I can also control, I want contours for these values of z variable. You can control it, but I didn't control here. So computer will decide 15 to 90. Now this corresponds to 15. This corresponds to 30, 45, so it is doing like that. Next is density plot. So as I said, different colors will mean different values, different strength of the function. Now there are two ways to do density plot. So all of it, one thing is common is called mesh. You have to make the mesh. So this mesh grid. So this part is common. Now I am making the figure size, all that is common. Now this is called image show. So this will plot z. Now is putting the minimum and maximum. So this whole thing is one line, okay, from here till here. So this will take care of plotting z. It's a 2D plot, so it will plot in that mesh. And I will put also color bar showing the strength of the function. And this is x axis, y axis. So this is same as before. So this is one way to do it. Another way to do is called function p color. So we can also plot density plots by using p color. Okay, so x coordinate, y coordinate, and z coordinate. Value of the function at x comma y. It's not a z coordinate, it's the value of the function. So this is called color bar. Now lowest is 0, it's increasing, you know, I mean I can't say everything is 0, increasing. So it increases slowly, so it reaches up to 0.2 somewhere here, then it has reached 0.5 here, then it has gone up to 1 somewhere. So this is how we can make a density plot. So a lot of scalar fields can represent very nicely with it. So I have made two files. This is only the p color. I think this is using p color. So you can make with mesh as well as p color. One of them I am not sure which one looks better. So I have it. You just play around with it. So we can make animation. We can also make particle trajectories in 3D. So that I may give as a homework. I think it's no, actually I can't give as homework. It's already there. You can make a particle trajectory. So it's again we'll be using axis 3D. So helical trajectory is drawn. I may have it somewhere later. Okay, so we can make nice animation. So I want to, so this copied from Reverse. This is a nice book. It does assume that you know a bit of programming. Okay, so this Python for scientists. So I want to plot this function at different times. So I'll plot f of x at different times, and it will move. So you'll see that it will move. So what is the, how does this function look like? Cos at a given time, let's say t equal to 0. So how does it cos hyperbolic? So cos hyperbolic 0 is, so you know everyone knows what is cos hyperbolic, no? Cos hyperbolic x is e power x by 2. So at x equal to 0 it is 1, and it increases. So it is 1. So for large x it will increase because of this, small x will increase because of this. It's an even function. Now I am inverting it, so it will be so this becomes 0, so it is a positive value, so square it. So it looks like Gaussian. So at a different time, so if I increase t, it will become 0 at maximum at that value of x. So this is going to shift. So this is for t equal to 0. Now t equal to 1, what happens to that? It moves to the right. Same function, this will correspond to x equal to 1. Okay, so this just shifts. So it's easy to write this code. So this is a function, solution t comma x. Now I use one property of this function called of PLT. It also returns something. So this line colon, there is other aspect which we don't want it. I mean it returns quite a few things. If I don't put comma, it will complain. So there are other values it returns, but you don't need to worry about it. How many does it return? I don't know, but so line contains x data and y data. So every plot has x data and y data, right? I mean it has created itself plot, but MATLAB will not allow you to do this stuff, you know. So here again basically get these features, and Matplotlib will tell you what all is doing. So x data is fixed. X data is here 0 to 60. It is 1001 points. Now when I do this, execute this function, I get x data will remain same, but my y data will change at different times. At t equal to 0 it is this, at later time it is this. So my y data, so value of y at every x is changing at different times, and that is what I need to feed in. So, for t in range minus 10 to 70, so I am running from time from minus 10 to 70, and how many steps? 161 steps, and I set the y data from this function at that time. So, this is a key feature. So, I am basically using this function and I set the y data, and you say use draw. So, you will draw at that time, and you will also put the title, and this sleep means it will not do anything, it will just sleep 0.1 second. So, otherwise it could be too fast. So, computers will just move very quickly and you will not be able to see this line move, this plot move, it just move too fast. So, I will let us run this one. So, this is where I am in the wrong directory. Okay. So, I have to go to the right directory. Okay. So, run animation. So, this is exactly the same code, I just run it. So, yeah, so 0.01, so I had changed this one, so let us put 0.1 and let us run it again. So, let us keep the figure file side. Okay. So, it is coming from the left, it is just moving. Okay. So, let us quickly finish the second one. You can make a movie. So, here I can't save it as a what format do you use for movies. So, many formats. So, one MPEG is one of the popular format. So, save in MPEG and then you can run it later. So, to make a movie, so this part is straightforward, so I just, this is a new function called draw frame and save each frame. Okay. So, in a movie, they just is static pictures which are run fast, not too fast, not too slow. So, at least 30 frames per second, right. So, this is in a loop. So, I will go from minus 10 to 10 with 101 frames, this number of frames. So, this part you have to be careful. File name is temp. Now, here I am going to put my name of the index of the frame. So, you will create lot of temp files and it will just pieces together. Now, each file will contain the one plot. It does exactly what movie makers do, and they just take a lot of pictures and they piece it together. And draw frame will plot it. So, this will make one plot and it will save it, and where does it save it? It saves in that file. So, when I loop it, I create a lot of temp files, and each temp file has a index. You can, in fact, you can run these programs, and when you look at the directory, you will get all these files, temp001.png. So, this is called PNG format. It takes less space and it will create there. Now, so this will create a lot of files. Now, I want to merge them together in a single MPEG video. So, now I need to use some other package. So, idea is to import so basically you run this function. You can run it from outside, but you can also run it from within Python. So, after the files are made, so this is not part of Python, you have to download this package ffmpeg. Okay. So, it will piece it together. So, all this is part of system, nothing to do with Python, but you can run within the Python. So, when I say import OS, so it is importing operating system. Well, it is not importing everything, whatever it needs it will have access to. So, first if the file exists, movie.png, it will remove it, old file will remove it. Then it is going to call this function. So, I have to give the path. So, my file is in this path, and this file, this syntax I copied. Okay. So, it will put the speed, how fast it will move, all that stuff is sitting here. You can control it, but I did not do anything. So, this is the file, all that file, it will file names, and it will make a new file called movie.mpg. Okay. And it will remove the temp files. We do not need the temp files, so it removes it. So, let us quickly run it. So, well, running it, so if I just run this, I get a movie. Okay. Now, I will run the movie instead of, in fact, it is right here. So, it is created by this. So we can replay it. Okay, so that sums up what all you can do. You can do lots of stuff. So if you look at Matplotlib, has a very nice website, and it has lots of examples. You can do scatter plot, you can make arrows, you can label, it can do tons of things. So I shared all of it. Plot 3D, yeah, plot 3D. So this makes this helical path. So this particle in a magnetic field. So I am going to use basically x comma y comma z, but I am using this axis 3D because this is a function. So this is what is going to achieve. So it is exactly same thing what we did for vector 3D, but I am plotting not in a mesh, but I am plotting x, y, z. So if I run this one, okay, and I can rotate this one. No, I have time. So this is just by the mouse, so you can just rotate. So this is trivial, but sometimes we want to see from different angles. You can also zoom it by zoom in out. Okay. So this is a right click and left click. That's it, nothing else. So it is very nice.